Welcome to a new lesson. In this lesson, we'll be discussing slope of a line. The slope of a line is a ratio between the rise of a line and the run of a line. A rise can go up or down, while the run will always be acknowledging as just goes to the right. So let's take a look at the first example. Determine the slope of each line segment. In this line segment AB, we notice that the A point is located specifically at grid intersection. What do I mean by grid intersections? We're looking at that occurs at a cross of the grid intersections. Why is that important? Simply because it is easily observed what the coordinate of A is. For example, I know that A will occur at -3 and -6, as x is -3 and y is -6. If A was to occur or be located somewhere right here, it would be harder for us to locate its coordinate points. Right now, this coordinate point is not important for the slope of this line, simply because we'll be just counting the run and the rise. So let's do that. Let's count across. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're moving across to the other coordinate point on the line, which is B. That means R8 is the run. While our rise will continue just going up. 1, 2, 3, 4, 5, 6. And this is our run. And our run is positive because we're going up. So what is our slope? The slope, again, is the ratio between the rise and the run. And we should always simplify this, if we possibly can, by dividing by the greatest common factor of 6 and 8, which is 2. So we divide the top and the bottom by 2, denominator and denominator by 2, so we get 3/4 as our slope. This slope means for every movement to the right of 4 units, we go up 3 units. Now let's take a look at the next question, which is part B. Find again the slope of this. So let's take a look. So we're starting at C. We're always starting on the left-hand side, and we go 1, 2, 3, 4, 5 units to the right. And that's our run. From that, we are going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. And that's our rise. And since it's negative, since it goes down, it's negative. Little typo right there in the 6, that should be, of course, the rise. So hopefully that didn't confuse you. And what the slope is of this graph, again, is the ratio between the rise, which is 10, negative, divided by the run, which is 5. And again, -10 over 5 can be simplified to -2 over 1, or just to -2. This means that for every 1 movement to the right, the graph drops 2 units down. Let's take a look at a different example. Draw a line segment with each given slope, 7/5 and -3/8. Again, this is a ratio of rise over run. And since the slope is positive, we know that the slope will go up and to the right. And for part B, since the slope is negative, we know the slope will go down and to the right. So let's draw these line segments. For this question, we don't need x and y axis because the graph can start anywhere on the grid. So let's pick a point for the 7 divided by 5 slope. So let's pick it right here. We know it's going to go up by 7 and right 5. So let's go right first. 1, 2, 3, 4, 5. That's the run. And now it's going to go 7 up. 1, 2, 3, 4, 5, 6, 7. Right there. And now we'll just connect the lines, the dots together. And this is 7 over 5 the slope is 7 over 5. So 7 is the rise. As for the negative 3/8 graph, let's start on top because we know the graph will go down because of the negative slope. So let's start anywhere on the grid, which is right here. And it will go across 8. 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is the run. And it will go down 3 units to 3. Connect the dots of a line. Hopefully it's straighter than mine. It's good to put an arrow because we know that it's going to continue. And here is our slope of negative 3/8. Of course, don't forget to indicate that it is the 3 is the run. Sorry, not the run, but the rise. Let's take a look at a different example. Determine the slope of the line that passes through specific coordinate points C, negative 5 and negative 3, and D, which has coordinate point of 2 and 1. So in this case, it's very important for us to draw the x and y axis and plot these points on our x and y axis, on our graph. So here are our x and y axis and our numbers on our axis. Let's plot negative 5 and negative 3. Recall that the first number in the coordinates is the x value, while the second is the y value. That means we're going negative 5, that means left 5, and down 3. And this coordinate is right here. It's negative 5 and negative 3. That's your C. And then D is we were going right 2 and up 1. So this is our D coordinate, which is 2 and 1. So the first thing we're going to do is we're going to find the run and the rise of the graph. So how many movements to the right? We're always moving from left to right. 3, 4, 5, 6, 7. There are 7 units that we're moving to the right. 7 is the run. And how many units are we going up? 1, 2, 3, 4. So 4 units up. So the rise is also positive because we are going up. So the slope is equal to 4 over 7. That is one method to find the slope. There is, however, another method to find the slope. Slope can be written as the difference between the y-coordinates over, or the ratio between the difference between the y-coordinates and the x-coordinates. What do I mean by these x-coordinates? Earlier, we talked about that the first number in the coordinates is an x value, while the second is the y value. And since we're dealing with points, the first point is our first x, while the first y is our first y, and the second point is our second x, and second y. We can plot these values into our equation, and we'll get the same answer as 4/7. So we have labeled first, so y2 is 1 minus, y1 is -3, so it's -3, over x2 is 2 minus x1, which is -5. We add or subtract the numerators first and then the denominators. 1 negative or minus -3 is 4, and 2 minus -5 is 7. Why? Because two negatives add up to a positive. They become positive. And here's your slope. So with our graphing, we're able to find the slope of two coordinate points, or a line that is between the two coordinate points. It's a very powerful method. Let's take a look at our last example. So we have Yvonne recorded the distance she had traveled at a certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba, from North Winnipeg to Grand Beach. She plotted these data on a grid. What is the slope of the line through which these points go? Then we'll explain the slope and what it represents, and we're going to answer some questions using the slope. The first method we'll use is just by the rise of a run and counting the run and the rise. So let's start with the first point. And we have a half an hour because a half occurs right there. And here's a complete hour. So the run is 1 hour. And now let's take a look at the rise. Now we have to look at the divisions. One little division is 6. Then second division is another 6, which is 12. Then another division, which is 18. And another division, 18 plus 6 is 24. So that means the rise is 24. And therefore our slope is rise over run. It's a ratio between rise over run. So it's 24, look at the units, it's kilometers, over 1 hour. So the other way to find the slope is not to use rise over run, but still use a different slope formula. But we have to know the coordinate points of all these points. So let's choose the first coordinate point, and that is 1, because it is 1 away from the x-axis, and it occurs at 24 kilometers. We'll use the last point, and the last point occurs at 3 hours, and the distance is 72 kilometers. The next part is to label these points: x1, y1, x2, and y2. I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1, and now we plug it in the specific y2 value and x2's values. 72 for the y2 minus 24 for y1 divided by x2, which is 3, minus x1, which is 1. 72 divided by 24 is 48, and 3 minus 2, so sorry, 3 minus 1 is 2, and 48 divided by 2 is 24, like above. Now, what does this slope represent? Take a look at the units that are used in the slope. The units is kilometers and hours. 24 kilometers per 1 hour. That means 24 kilometers have been traveled in 1 hour. That explains speed. How fast you're traveling, 24 kilometers per hour, it's a rate. Now we're going to use the slope to answer part C. How can the answer to part B be used to determine how far Yvonne traveled in 1 hour and 3/4 of an hour? Also the time it took Yvonne to travel 55 kilometers. So remember that the slope tells us that 24 kilometers are done in 1 hour. And since we're going to have 1 hour and 3/4 of an hour, what's the distance traveled? So we're going to multiply by 1 point. Well, 3/4 is 75. How do we get 0.75? Because 3 divided by 4 is 0.75. And add it to 1. And since that's hours, I'm going to multiply. Why we multiply is because hours over hours canceled, and we get only kilometers. We get distance in this case. So 24 times 1.75 is 42 kilometers. So in 1 3/4 of an hour, 42 kilometers was traveled. What about the time it took Yvonne to travel 55 kilometers? Well, that should be more than 1 hour and 3/4 of an hour. And let's give ourselves some space and erase the slope calculation. So we know that we're looking for time at which 55 kilometers was traveled. And what we're going to do is we're going to flip the slope upside down. So we have 1 hour and 24 kilometers. Why do we do that? Is because when we multiply these two values together, we have kilometers that will cancel, and we have only units of hours left. That means we are calculating for time. So 55 divided by 24 is 2.29 hours. Again, how do we do this? We took 55 divided by 24. But this 0.29 doesn't really make much sense to us. What's 0.29 of an hour? So that's a little bit of confusing. We have to convert this to minutes. Well, how do we convert the 0.29 to minutes? Multiply this by 60. Why? Because there are 60 minutes in an hour. So take a look. Again, because we have a fraction, hours will cancel when we have minutes left. So the answer will be in minutes. So the answer is approximately 17.5 minutes. So the entire answer now is 2 hours and 17.5 minutes. That's how long it took Yvonne to travel 55 kilometers.